Hey everyone, today we're going to be talking about hydrocarbons, which is the basis of organic chemistry, what we're looking at right now. Just like with all other parts, I wanted to start off by taking a moment to look over like the parts that are making up this word so we can have an understanding of what this means. So take a moment, look at that name, hydrocarbons, and think about what kind of elements are probably going to be creating something like hydrocarbons. So hopefully you saw this hydro part and it made you think about hydrogen. And well, we've got carbon here, carbons, and so hopefully that made you think about carbon. And so when we're thinking about hydrocarbons, we're thinking about something that is going to be mostly made up of hydrogens and carbons. So why? Why is it that we're talking about something like carbon? Because hydrocarbons really do come down to the fact that we have carbon, and carbon's really special in a lot of ways. So if you think back to all of the Lewis dot diagrams that we have done in the past, you'll remember that carbon in the fourth column has 4 valence electrons. And this makes it really special because carbon can do a lot of things because it's able to make 4 bonds. There's very few elements that are able to do that. So carbon with another carbon is able to make a single bond, 1 bond. It can also make a double bond, so 2 bonds in between the carbon elements. It can also make 3 bonds in between the 2 elements of carbon. And then often what we would see is something like a hydrogen filling in any of those spaces where carbon did not bond with another carbon. So we could see something that looks like this, which has 2 carbons with single bonds in between them, and hydrogens filling up all the extra space. We could see something like this, which has carbon with some double bonds in between them, and hydrogens filling up all of those empty spaces. We could also see something that looks like this, where we have carbon with 3 bonds in between them, and again, hydrogens fill in that empty bond. One of the things I want you to notice is that for each carbon has 4 bonds. So this carbon has 1, 2, 3, 4 bonds. This carbon has 1, 2, 3, 4 bonds. And even this one has 1, 2, 3, 4 bonds. So when we're talking about carbon, it is a really special kind of element because it's able to create all of these different bonds with each other. And also hydrogen is, so we think about this as like a carbon backbone. Just like your backbone or your spine provides the structure for the rest of your body, carbons can provide the structure for a lot of different compounds that we're looking at. So something that I want to make sure that you copy down and you have a list of. Some of these things might look a little bit familiar if you remember anything to do with naming previously. Other things might be a little bit less familiar. So we talk about these as prefixes. And these are things that we put in front of our name to show how many carbons we're talking about. Okay, so when we happen to use the word meth, we're talking about 1 carbon. When we say eth, we're talking about 2. 3 is prop. 4 is bute. 5 is penta. 6 is hexa. 7 is hept. 8 is oct. 9 is known, and 10 is dec. So hopefully some of this stuff looks similar to you. This stuff may not necessarily be as familiar, but this hopefully has some kind of connection to what you've done in math so far. So if we're thinking about something that has 5 sides, we call it a pentagon. If we happen to have something that has, or a pentagram, if we have something that has 6 sides, it's a hexagram. Or something that has 8 arms is an octopus. When we're talking about 10 years, we're talking about a decade. So these are things that we just want to keep in mind when it comes to indicating how many carbons we might have in some kind of structures. So we're going to talk about a couple of different types of carbon compounds. The one we're going to focus on today is something called alkanes. And alkanes are molecules that have single bonds between the carbons. So we can get some really long lines of these single bonds between carbons, and we're going to be able to indicate by name what they are based on how many carbons they happen to have in them. We do have a couple other ones that we'll come to in the next few days. So we have alkanes, and I want you to notice that we have this A there. So A is for that single bond. We also have something called alkenes that we'll talk about soon enough. And this is when we have double bond existing in that compound. So the big difference between our first one and our second one is that here we have an A, here we have an E. We also have another one called alkynes. Oh, sorry about that. Let's try that again. Alkynes that are between when we have triple bonds between carbons. So we're going to come to these other two later, but one thing to pay attention to is that if you can remember that there's an alkane, alkene, and alkyne. A is it's the earliest letter in the alphabet, and it's the smallest number of bonds. E comes after A, so we're kind of going through some of the vowels here, and that's a double bond. And Y is the last vowel that we have in the alphabet, and that is a triple bond. So just as we kind of move throughout the alphabet, we also add on different numbers of bonds. So let's take a look to see what something like this might look at. If we're going to be looking at something like an alkane, we are going to be looking at, so let's say that we wanted to talk about methane. The fact that there is meth is telling us that there is one carbon that's going to be part of this molecule. So we are going to start off with our carbon, and we know that there's going to be 4 bonds. So I can go ahead and draw those bonds in here. Because there's only one carbon, I know that there's not going to be any other carbons that I add. And because it's a hydrogen, I know that we're going to be using hydrogens to fill in all the remaining bonds. So me drawing methane, I would just add hydrogens around my carbon so that all the bonds have something that they're connected to. So there's my methane. Let's say that I wanted to draw ethane. Because of that eth, I know that we're going to have 2 carbons. So I'm going to draw my 2 carbons. Because of this ane here, I know that we're also going to be having just single bonds. So I don't have to worry about putting any other bonds between this. Now I've got each carbon has 1 bond, and so I have to add 3 more bonds to each carbon so that each carbon has 4 bonds. Now keep in mind that 1 bond equals 2 electrons. So we still have 2, 4, 6, 8 electrons with each carbon. And just as before, I'm going to add hydrogens to fill up all of those bonds that I have. Let's try something that's a little bit longer than that. Let's try hexane. So because it's hex, I know that's going to be 6 carbons. And again, that ane is telling me that everything is going to be in single bonds. So I'm going to put in 6 carbons connected by single bonds. Now here I've got to think a little bit more because I want to make sure that each carbon has exactly 4 bonds. So for these outside carbons, I'm going to add 3 more bonds because they only have 1 bond with the carbon beside it. However, with all the other carbons, it has a bond with each of the carbons on the side of them. So it already has 2 bonds. So all of those ones on the inside, I'm going to just be adding on 2 more bonds. And then I always want to double check to make sure that each carbon has 4 bonds, no more, no less, connected to it. Once I've done that, I'm going to go through and then fill out the rest with my hydrogens so that everything has its valence orbit complete. So this is what hexane would look like. Now we'll go on and we'll try a few of these in the worksheet that you have provided to you. If you have any questions, just make a note and we'll talk about them in class. But go ahead, try it. Use this nice little handy naming system that we have here to remind you of how many different carbon bonds there are. So if you haven't already, take a moment to write this down so you have something to refer to. One of the things that I want you to pay attention to is when you're looking at the number of carbons you have and how many hydrogens you have. So here we've got 1 carbon and 4 hydrogens. Here we have 2 carbons and 6 hydrogens. Here we have 6 carbons and we've got 14 hydrogens. Take a look at those numbers and on the list that on the worksheet that you're working on, and we're going to come back and pay attention to what those numbers mean, because there's actually a nice little short form we can use to figure out how many hydrogens we have once we know how many carbons we have. But that's it for today. Hope that made sense, and we'll talk more when I see you in class.